Hello everyone. Today we're going to finish section 2.2, parts C and D. So we need to find the vertex, x-intercepts, y-intercepts, and then graph these functions. So for C, we have 1/2 x squared plus x minus y equals 3. Before we can do any of that, we need to get it in standard form. So I'm going to subtract 1/2 x squared and subtract x from both sides. So we get negative y equals negative 1/2 x squared minus x plus 3. Then we divide by negative 1 on both sides. So we get y equals 1/2 x squared plus x minus 3. Now to find the vertex, we have the formula negative b over 2a for the x value of the vertex. So that means x will equal negative 1 over 2 times 1/2. When you simplify that, we get negative 1. Then to get the y value of the vertex, you plug negative 1 in for x. And if we simplify that, we get negative 3.5. So our vertex is negative 1, negative 3.5. Next, let's find the y-intercepts. So that's where you plug 0 in for x. So we get y equals 1/2 times 0 squared plus 0 minus 3. That comes out to be negative 3. So our y-intercept is 0, negative 3. Now let's do our x-intercepts. That's where you plug 0 in for y. So we get 0 equals 1/2 x squared plus x minus 3. Now I am going to use the quadratic formula to solve this equation, but first I am going to multiply everything by 2 to get rid of the fraction. So 0 times 2 is 0, 2 times 1/2 is 1, so 1x squared plus 2x minus 6. And like I said, I'm going to use the quadratic formula. So that's negative 2 plus or minus 2 squared minus 4 times 1 times negative 6 all over 2 times 1. Which is negative 2 plus or minus 4 plus 24 all over 2. Which is negative 2 plus or minus square root of 28 all over 2. The square root of 28 can be reduced because the square root of 28 is equal to the square root of 4 times 7. And the square root of 4 is 2, so we get 2 square root of 7. So we get negative 2 plus or minus 2 root 7 all over 2. Now I can reduce these 2's to 1's. Now you can only do this if you can do it to all terms in the fraction. So since this fraction has 3 terms, I would need to do it with all 3 terms. And we get negative 1 plus or minus square root of 7. Now since I want to graph these, I do want approximate answers. And you do that by going negative 1 plus the square root of 7, which is approximately 1.6, and negative 1 minus the square root of 7, which is approximately negative 3.6. So our x-intercepts are 1.6, 0, and negative 3.6, 0. Now with these 2 points, the x-intercepts, our y-intercept, and our vertex, I'm going to graph that on some graph paper. So our vertex first, negative 1 to negative 3.5. Y-intercept 0, negative 3. X-intercept 1.6, 0, negative 3.60. And we get an upward facing parabola for our equation. And there's a neatish sketch of part C. Now for part D, we have f of x equals to x squared minus 6x plus 9. Now it's already in standard form, which is good, so I can jump straight into the vertex formula. So the vertex, again, is negative b over 2a. So negative 6 all over 2 times 1, which is 3. And then we need f of 3, which is 3 squared minus 6 times 3 plus 9, which is 9, negative 9, 0. Comes out to 0. So our vertex is 3, 0. When your vertex is an x-intercept, because it has y for the 0, that means it's the only x-intercept. So I'm not going to have to do any work for the x-intercept. This is my only one. But we still need to find the y-intercept. That's where you plug 0 in for x, so that would be f of 0, which is 0 squared minus 6 times 0 plus 9, which is 9. So we get 0, 9 for the y-intercept. And again, and this only works when the vertex is an x-intercept. You don't have to do any work. Our x-intercept is 3, 0. There aren't any others. Well, we have 2 points. And then knowing the symmetry of a parabola, we're going to get a third point so we can graph these. So 3, 0, 0, 9. Then using symmetry, I go over to here to 6, 9 for my third point. And try to make it symmetric. I am a little bit more curved on this side than that side, but try to do your best. And that is it for section 2.2.